In the star get-together Orion, there is a star that has enchanted cosmologists for a truly broad time period. Betelgeuse. This red, particularly colossal star is significantly more massive and greater than our Sun. In recent years, Betelgeuse has been acting particularly peculiarly. It has dimmed significantly and has even started to vibrate violently. This has provoked speculation that this once lavish star is advancing toward a grand explosion. Yet, ponder this. What if we are truly witnessing the start of a more precarious and disturbing event? Consider the possibility that Betelgeuse will not explode but, instead, collapse on itself. Join us as we explore the latest research on Betelgeuse and its potential consequences for our planet. Through this assessment, we aim to understand the fundamental impact Betelgeuse's collapse could have on the future of the universe. Betelgeuse is a tremendous star, many times larger than our Sun, and is among the universe's largest. However, its size comes at a cost. Stars like this have limited lifespans, and Betelgeuse is no exception. It's a ticking time bomb, ready to explode, yet the precise moment remains a mystery. Situated around 650 light-years away, Betelgeuse has fascinated cosmologists, shining as one of our nearest stars. We marvel at its brilliance, endeavoring to unravel the mysteries concealed within its fiery depths. However, only 13.3% of its magnificent energy is visible to us. If we could see its full glory, it would outshine even Sirius in the night sky. Imagine a titanic star with a radius roughly that of our Sun, extending beyond the asteroid belt and nearly reaching Jupiter. Within this colossal region, Earth, Mars, Mercury, and Venus would be engulfed by Betelgeuse's immense gravitational power. Yet the surprises don't end there. Every few hundred years, Betelgeuse sheds a solar mass, pushing off its outer layers in a brilliant display of cosmic beauty. A cloud, often larger than the star itself, envelopes Betelgeuse, covering it in an ethereal fog that captures our gaze. This cloud, extending 30 light-years, invites us into a grand cosmic dance, urging us to uncover its secrets. Let us delve deeper into the heart of Betelgeuse's creation, where the nuclear fusion of hydrogen creates helium in an enormous release of energy. Over time, as the star's hydrogen fuel diminishes, a dramatic transformation occurs. Helium fuses with carbon, producing a brilliance that travels through the universe. But even this incredible fusion has its limits. As neon combines with iron, a catastrophic change happens. The star's gravity, weakened by the loss of energy, triggers an impending collapse, pushing Betelgeuse toward a fate that is both dramatic and terrifying, a cataclysmic explosion. Stars undergo a mesmerizing transformation, evolving from the dynamic blues of youth to the blazing reds of old age. During the 2nd century BC, Chinese stargazers observed a peculiar phenomenon. Betelgeuse's distinct yellow hue set it apart from the celestial tapestry. As centuries passed, the mantle of observation was handed to Greek and Roman stargazers like Hipparchus in the 2nd century AD. In his detailed accounts, he described Betelgeuse as having an orangish or tanned appearance, a characteristic that still captivates us today. This persistent tone, noted across various cultures, adds to the fascination surrounding Betelgeuse. The story of Betelgeuse takes another twist as we delve deeper into its eccentric behavior. In 2019, the star baffled experts by suddenly dimming. At first, astronomers believed a massive dust storm released from the star's surface had obscured our view. However, the origin of the cloud remains unclear. Some researchers hypothesize that a massive object like a planet could have disrupted the star's surface or even been consumed by it. Recently, Betelgeuse has become twice as bright as its usual brightness. This is surprising, as stars typically dim as they age. Experts are uncertain about the cause of this sudden increase in brightness, but they know that celestial luminosity can vary due to many factors. Some stars go through cycles of brightening and dimming. Betelgeuse is classified as a variable star, as it changes in brightness, expanding and contracting regularly, altering the amount of light it emits. This is a common phenomenon with many stars, including Aldebaran and about 30 other stars visible in the night sky without a telescope. Within Betelgeuse's core, a seismic shift is occurring, releasing vast amounts of material into space, creating a massive dust cloud of tremendous proportions. This dust cloud obscured a significant portion of Betelgeuse's brilliant light, transforming it from a striking beacon to a dimmer star in the night sky. Betelgeuse's brightness dropped to levels previously unheard of. Once considered among the top 10 brightest stars, it now ranks lower than the 20th brightest. In recent years, Betelgeuse's behavior has astonished astronomers, challenging the norms of stellar behavior. Some suspect massive sunspots or dust clouds are responsible for its dramatic changes, while others have examined the possibility of repeating patterns. Their research has revealed the unsettling possibility that Betelgeuse's massive explosion may have already occurred. Yes, you heard that right. While past estimates projected its grand explosive event to be centuries away, current evidence suggests a different story. The massive explosion could be the next major celestial event in our galaxy. Experts propose a model recommending that scarab juice is in the late periods of carbon consumption, showing it very well may be moving toward a huge blast. This positions Betelgeuse as a solid competitor for the next expected grandiose blast in our Milky Way. Anticipating the specific timing of a supernova is a perplexing and challenging task. While scientists can gauge the likelihood of a supernova based on a star's age and behavior, precise predictions are difficult due to the many variables involved. Factors such as the star's mass, composition, and overall environment can influence the timing and nature of the blast. Current models of stellar evolution and supernova mechanics provide valuable insights, but much still needs to be understood about the specific conditions that lead to a cosmic explosion. Continued observations of Betelgeuse and other massive stars are essential for refining these models and advancing our understanding of these remarkable cosmic events. The study of Betelgeuse offers critical insights into stellar evolution. By examining the star's behavior and characteristics, researchers can gain a deeper understanding of the life cycles of other massive stars and the processes leading to supernovae. Betelgeuse's unique properties, such as its size, brightness, and erratic behavior, provide valuable data for developing and testing theoretical models of stellar evolution. Moreover, studying Betelgeuse's interactions with its environment and its potential supernova will contribute to ongoing studies of cosmic evolution, influencing the formation of new stars and planetary systems. The dramatic nature of Betelgeuse's behavior has captured the public's imagination and sparked widespread interest in astronomy. Educational outreach programs and popular science articles often highlight Betelgeuse as an example of the fascinating and dynamic processes occurring in the universe. Public engagement with such topics fosters interest in science and promotes a broader understanding of celestial phenomena. As technology continues to advance, future observations of Betelgeuse will provide even more detailed insights into its behavior and evolution. New telescopes and observational methods will allow scientists to monitor the star's development with greater precision, revealing additional clues about its impending supernova. Researchers are also exploring the use of computational models and simulations to better understand the processes occurring within Betelgeuse and other massive stars. These models help predict the star's future behavior and refine our understanding of the mechanisms driving supernovae. The study of Betelgeuse offers a fascinating glimpse into the life cycle of massive stars and their impact on the universe. From its immense size and complex fusion cycles to its potential as a supernova candidate, Betelgeuse remains a central focus in the field of astronomy. As we continue to explore and understand this exceptional star, we gain invaluable insights into the dynamic processes shaping the universe. Its eventual explosion will not only mark a spectacular event in the cosmos, but also contribute to the ongoing cycle of star formation and chemical enrichment in our universe. Betelgeuse's impending supernova holds an interest for astronomers and the general public alike, as it promises to be one of the most stunning cosmic events observable from Earth in centuries. Yet beyond the sheer brilliance of such an explosion, its occurrence also offers a deeper understanding of the processes governing stellar life cycles. This massive star, like others of its kind, is a crucial laboratory for astronomers trying to unravel the secrets of how stars live and die. Stellar evolution is a complex process driven by the delicate balance between a star's mass and the forces at work within its core. For stars like Betelgeuse, which are classified as red supergiants, the cycle of nuclear fusion accelerates and reaches its final stages much faster than in smaller stars like the Sun. While our Sun is expected to live for approximately 10 billion years, stars like Betelgeuse can go from formation to their final explosion in just a few million years. This dramatic difference in lifespan is primarily due to the way larger stars consume their nuclear fuel at a much faster rate, a process that ends in the formation of elements much heavier than hydrogen and helium. As Betelgeuse approaches the end of its life, the core of the star is primarily composed of helium, carbon, and oxygen. In the core, the fusion reactions that sustain the star for millions of years begin to wane as the star exhausts its hydrogen fuel. The core contracts under the force of gravity, causing temperatures and pressures to rise dramatically. As this happens, the outer layers of the star expand, increasing its size immensely. These outer layers, composed of hydrogen and helium, are the parts of the star we see as Betelgeuse in its current form. These expanding layers result in the star's red color and enormous luminosity, making it one of the brightest stars in the night sky. Despite its immense size, the outer layers of Betelgeuse are relatively thin compared to the core. They are held in place by the fragile balance between the gravitational pull of the core and the outward pressure from the fusion reactions. As Betelgeuse runs out of fuel, this balance shifts. The fusion processes slow down, and the core's gravity becomes stronger than the outward pressure, initiating a catastrophic collapse. During the final stages of a red supergiant's life, the star undergoes a process known as core collapse supernova. When the core reaches a point where it can no longer support itself under the force of gravity, it collapses inward at an incredible speed, compressing the material into a much smaller volume. The outer layers of the star are then ejected outward in a massive explosion that releases energy equivalent to the energy output of the star over its entire lifetime, often brighter than the entire galaxy containing the exploding star. This type of supernova is one of the most powerful events in the universe, and it can outshine an entire galaxy for a short time. The explosion also plays a crucial role in the cosmic cycle, enriching the surrounding interstellar medium with heavy elements such as iron, nickel, and silicon. These elements, forged in the star's core, are dispersed into space during the explosion. The debris from the supernova serves as the building blocks for the formation of new stars, planets, and even life as we know it. Beyond the magnificent display of light and energy, supernovae like the one expected from Betelgeuse offer priceless information to astronomers. By studying the properties of the explosion, scientists can learn about the underlying processes of stellar evolution, the physical properties of matter under extreme conditions, and the chemical composition of the universe. Supernovae act as natural laboratories that provide insight into the mysteries of the cosmos, allowing astronomers to test and refine their theories about how stars form, evolve, and die. Interestingly, Betelgeuse's eventual explosion could also have significant implications for the nearby environment in the Milky Way galaxy. While the supernova itself will not be dangerous to life on Earth, it will significantly impact the local cosmic environment. The shock waves and radiation generated by the explosion could trigger the formation of new stars in nearby molecular clouds, creating new systems of planets and stars. The elements released by the supernova could also contribute to the formation of new stars and planetary systems, continuing the cycle of cosmic evolution.